Let's solve a system involving three variables. All right, there it is in all its glory here. X plus y plus z equals 6. 3x plus 4y minus 7z equals 1. 2x minus y plus 3z equals 5. All right, we're going to use the addition approach here. But the first thing we have to do is use 2 of the 3 to eliminate one of the variables. So this one sets up well. Notice we have a plus y and a minus y. So I'm going to add the two equations. I'm going to add equation 1 and equation number 3. By adding those together, kind of down our columns, we're going to come up with 3x plus 4z is equal to 11. And again, this is a little bit different than we're used to in the past. Now we're going to get rid of the y's using the first and the second equation. And the way we'll do this is by multiplying the first equation, both sides of that equation, by a negative 4. All right? So let me write that under here. We'll have a negative 4x minus 4y minus 4z. That is equal to a negative 24. And remember, we're going to add that here to equation number 2. So we get 3x plus 4y minus 7z equaling 1. And again, by design, when we add down those columns, those y terms disappear, and we obtain a negative 1x minus 11z is equal to a negative 23. Now we have two equations and two variables, and it's a little bit bothersome that it's in terms of z, but we can handle it. We'll now do just like before, solving systems of equations in two variables. And let me line these two up here quickly. Okay? So probably want to go with the addition approach, get rid of the x's. So I'm going to multiply both sides of the second equation by 3 here. All right, let me rewrite the first one. 3x plus 4z equals 11. And our second equation will look like the following. A minus 3x minus 33z is equal to a negative 69. So by adding down those columns once again, the x's disappear. From this, we get a negative 29z. That is equal to a negative 58. So let's isolate z entirely by dividing both sides by a negative 29. All right, so let's bring this up here. Got quite a bit going on the page. From this, we get a nice answer of z is equal to 2. All right, we're looking for an ordered triple in this case, something of the form x comma y comma z. We now have the z value. Now our job is to find the next variable, which in this case is x. And this is already decided for us. Since we removed y's initially, we have two equations in terms of x and z, so we're going to find x. And I'm going to plug this into our 3x plus 4z equals 11, replacing z with the 2, and then solving for x. And quickly, if you run that through, you get a nice answer of x equals 1. So this is the x coordinate for our ordered triple. Now if we plug x equals 1 into the original, z equals 2 into the original, we can find our last remaining coordinate. So let's do that here quickly. 1 plus y plus 2 in this case. That is equal to 6. And it's pretty obvious that y is equal to 3. Now let's bring all this together. Let's take our pertinent information and write our answer correctly. We have our x equals 1, y equals 3, and z equals 2. And to write that correctly as an ordered triple, we have 1, comma 3, comma 2. And this is the intersection point of these three equations in terms of three variables.